So for my citizen science project, I chose to do Cyclone Center, which is over hurricanes. One reason that I chose to do this project is because I don't know very much about hurricanes. I just know that they are big tropical storms that usually devastate the areas that are hit by them. And we had Hurricane Michael going on recently, so I'm kind of curious. So what are scientists trying to answer by doing this project? They are trying to better predict future cyclone behavior and their wind speeds and how their nature might be. So by looking at previously collected data throughout history, we can see that wind speeds that were recorded are very inaccurate and inconsistent. And this makes it kind of harder to estimate the strength of the cyclones and how climate change has affected their nature. So scientists believe that by answering a few specific questions and using the human naked eye with the Dvorak technique, we can use these satellite images to categorize storms and better predict them more so than future technology can, such as computers. The methods that I have used to help climatologists figure this out and further these studies would be observing satellite images of previous storms and cyclones that have occurred throughout the years. And I've done this by observing their color of clouds, which can be blue, red, yellow, orange, pink. I've observed their banding size, their strength, their shape. And by doing this, I can categorize what type of storm it is and also maybe estimate the wind speed. So what are the different types of storms and how can they be identified? First, we have the ice storm, which is the most powerful. Oops, where did we go here? And then we've got the first image right here is just a regular picture of an ice storm taken from above, and we've got the eye right here. And then we have the infrared satellite image to its side. We've got the cold clouds at the center, which is the eye, and then the red and yellow is the warmer clouds. And then next we have embedded centers. These types of storms have a roundish area of cold clouds near the center, as we can see here. They're weaker than ice storms and stronger than curved bands. And weak embedded centers can appear to be like curved band storms, while strong embedded centers may start to form an eye, which this one right here has not yet. Curved band storms are a little bit harder to identify and they appear more disorganized, more so than embedded centers. You might want to look for a comma-shaped storm with a round area of clouds at the center. So we can see here this one has that comma shape. It's a little bit more disorganized in the shape and spiral. It's got a little bit more of a curved band to it, more so than the others. Shear storms are most easily recognized by a flattened side with all the colors smushed very close together, and a vertical shear causes the tallest clouds to be displaced to one side. So here we can see all the colors are smushed. They're kind of flattened out. And we've got the cold clouds, which is the blue, put off to one side, and the yellow, orange, and red, which is the warm clouds, put off to another side. Shear storms are usually pretty easy to recognize. Other categories of storms, if you cannot fit it into the first four, one of them would be post-tropical. So these storms are usually identified by large amounts of warm clouds and a long tail extending from the center. As we can see here, it extends out. There is lots of orange, yellow, and red going on here, as well as pink clouds in the background. There is almost no blue in this image. And edge storms would be next. They are sometimes a little bit blurry, pixelated, or skewed, as we can see here. It's got some black streaks going on in it. This storm is not normal and is usually almost always classified as an edge. Next, we have no storm. This is kind of earlier on in a storm's lifetime or formation. You might not be able to say anything about its shape or spiral structure yet, or it may not have one. So I could not find an image of this alone. So we have up here in the top left corner, it has really no spiral structure, shape, or band going on yet, so this would be classified as a no storm. So in my observations between September 19th and October 19th, I observed about 22 different satellite images of cyclones and tropical storms. And out of these 22 storms, there was 4 no storms, 5 embedded centers, 5 curved bands, 4 shears, 2 edges, and 2 post-tropicals. And that all adds back up to the same number that we got up here. So will these results help climatologists? I believe that my observation and estimations can help better predict the future nature of these cyclones and tropical depressions. And it is in my opinion that the human eye can typically notice and see more than technological devices, which might overlook certain things as they are programmed to only see certain things or whatever a person is wanting to find. So by knowing how to better predict these storms, we might be able to tell ahead of time when a storm is going to occur, what its nature might be like, the main locations that will be affected, and many, many more things. We can also figure out if climate change has a big impact on these cyclones, and if so, we can identify ways to significantly reduce global warmings and find alternatives to living that are more environmentally friendly. When it comes to the scientific method, I believe that I learned how to do observations a lot better as well as make hypotheses. And I learned that hypotheses are not always going to be correct. So when I am looking at these images, I know sometimes that I'm very much not accurate or correct. I have learned how to analyze and draw conclusions more as well as report data. Try to make sure as best as I can that when I report it, it's correct, but it will not always be. Here's my references right here, cyclonecenter.org. And really, really quick, I'm going to go to the Zooniverse website. Here's a little bit of what we do. We will compare storms, pick which one you think is the stronger image. And then we kind of have to look at it and decide what it is. So I'm going to go over here. Whoops. And this looks like an edge storm because it is pixelated. And then we can scroll down and it will tell us what type of storm it is, where it has occurred, its wind speed and air pressure, and there's many, many more things that you do on here. So you just kind of compare them and pick the stronger ones, what their band sizing might be. You can look at the colors of the clouds. So we're just constantly going through here and doing this every hour. And one thing that I found very, very interesting about this project, excuse me, I found it interesting how one storm can turn into so many different kinds of categories in just a short amount of time or by a small little shift. So, for example, we had Hurricane Goni that occurred several years back, and it went from shears to embedded centers. Or we also had Gianna, and it went from weak curved bands to shear storms, and they can just shift so dramatically. But I found that highly, highly interesting, and it was very, very neat to do this project. It's something I've never done before.